Hello students, welcome to the course Network Theory. In the previous video, I discussed Millman's theorem. It is a statement and proof, and also we have seen two examples problem for DC networks. Okay, so in this video, we'll solve some more problems on Millman's theorem. Now there are some AC elements also present there. Okay, so with that we will be solving. So first problem I will elaborate much. Okay, then remaining two are same. Okay, so just we can quickly go through. Okay, so have your notebook, pen ready, and also have the calculator. Okay, okay, we'll begin. So note down this question. So using Millman's theorem, find the current flowing through 4 plus J3 ohm of the circuit shown in figure. Okay, so 4 plus J3 ohm means what? It is a load. Okay, so it will be single element present in your network. See here. Okay, so my handwritten, okay, so notes it is copied, so just bear with me. Okay, so 4 plus J3, these are in series. Okay, so there was some problem happened, so that's why 4 plus, so above it is drawn. Okay, so it is not parallel, it is in series. 4 plus J3 ohm. Okay, so like this, 4 plus J3 ohm, and these are generators, voltage sources in series. Okay, so these are 100 at an angle 0 degree volt 5 ohm, 90 at an 45 degree volt 10 ohm, and 80 at an angle 30 degree 20 ohm. And see here, the current direction is in this direction. Okay, voltage direction is in this direction, and but for this it is reverse manner. Okay, so even while copying I also confused, so there was both side it is showing, but it is upward this side. Okay, right side, and these two are left side. Fine. So you have to be your calculator in complex mode here to solve, because the rectangular form is there, and this is in polar form is there. Okay, so calculator will take, you can enter either way. Okay, you no need to convert in any one form, not required. Okay, okay, so as per the theorem we will go through for this problem, so you no need to simplify anything here. So straight away use the formula, and in formula you substitute the values and you will get the result. Okay, so just note down this network. Okay, I will go through further, so you can just pause and note down. Okay, so whatever circuit is shown there, I can make it into, according to Millman's theorem, I can make it into a single voltage source in series with impedance or resistor, whatever they have given, and there is a load connected here, because we need to find the current in this circuit, right? So for that it is shown here current like this, because the direction of voltage is, that's why current is shown like this. Clear? So now you used to use the, we'll use the formula for Millman's theorem. E is equal to, there are three sources are in parallel, that's why I have used only E1 E2 E3 and Y1 Y2 Y3, and the third source I am having negative, right? So opposite to these two, that's why it is made minus. You can make these two minus, and this also you can make plus, no difference. Okay, it will give the same answer. Okay, so in the formula only I have changed it. Again, when substituting, no need to do the minus, as it is you will enter the magnitude. Okay, so enter now first source, okay, which is on the top. It is having 100 at an angle 0 degree, and the resistor value is 5. Okay, so that you write. Then second source you have 90 at an angle 45 degree divided by 10. Next you have the opposite, right? So that one you write 80 at an angle 30 degree by 20 ohm, divided by y1 plus y2 plus y3, nothing but 1 by z1 plus 1 by z2 plus 1 by z3, nothing but these resistors, 1 by 5, 1 by 10, and 1 by 20. Okay, so now you require the calculator. So straight away I have given the answer, but it is not so magic, right? So one step you can write here. Okay, so what is that step is, this you can divide straight away. Okay, so it is here, j term is not there in denominator. When j term is not there, so straight away you can do this division. Okay, so simple division, no, 100 by 5 means 20, right? So you write 20 at an angle 0 degree. Okay, so write one step. Okay, here if you want, okay, you write it better. Okay, first time you are doing, no, do it. So 20 at an angle 0 degree, then what you have, 90 by 10, that means what, 9 at an angle 45 degree minus 80 by 20, nothing but 4 at an angle 30 degree. Angle it will not affect, because only magnitude term is there. J term is there, then it will affect. So j term is there, you should use calculator only. Okay, So this one you can do with your oral mathematic calculation. Okay, so this 4 times. Okay, so this 9 times, here it is 20 times. Okay, divided by, so don't only stop there. So divided by, you can do this calculation in calculator. 1 by 5 plus 1 by 10 plus 1 by 10t. So how much it will come? So use the bracket and write 1 by 5 plus 1 by 10 plus 1 by 20. Okay, I have not made any video to show you. Okay, already I have shown this part. Okay, so I am getting the answer for this is 0.35. Okay, so the denominator part I'm getting 0.35. So now you use your calculator in complex mode. Okay, so complex mode because angles are there. So you substitute now. So 20. Okay, 20 at an angle. How you do? Shift minus something is there. RCL above. I have shown earlier how to enter the angles. 20 at an angle 0 degree plus 9 at an angle 45 degree. Degree no need to show, just 45 if you write enough. Minus 4 at an angle 30. Okay, so this you can equate it. Okay, so this you can equate it and write the answer. So normally if you give in angle form also, the answer will come in a plus bi form. Okay, so some value, then shift equal to you make, so you'll get the I part. Let it be, you copy down that and divided by 0.35 as it is, you write. Then you convert it into, or then you can divide by this into 0.35, so you'll get some new values. Then that answer you can convert. Okay, as I shown you, polar form to rectangular form. How to do? Once you get the angle, so shift, press the plus button, so that is r at an angle theta will come, give answer equal to, then the answer will come straight away. 66.6 will come in the first, then you give shift equal to, then you will get the angle, it is 10.78 degree volt. Okay, so you can do this calculation. As you done the calculation, you can tell me in the WhatsApp, sir, we have done it, so understood it. Okay, otherwise I have to make a video and you have to show you. Clear? So I hope all these parts I have done in previous videos one by one. Okay, so in the mesh analysis of AC network, node analysis of AC network, we have gone through such cases and I have already done it. If you have not seen that video, just you can refer that video. I have loaded the video of how to do that. Okay, uh, that's it. So you will get the answer here. Okay, so this is the answer for E now. So similarly you need to find the second part, that is Z. Z is nothing but what? So this ratio 1 by this ratio, if you take, you will get that, that is nothing but 1 by 0.35. Okay, just we will see that. So I suggest you to do some work. Okay, because as an online work we are doing lots of work here. Okay, so making notes, then scanning it, then uploading it, then conducting class. Okay, so recording it, and after that uploading, then sharing with you. Okay, so lots of activity are happening more than the regular classes. Even we are eager to start the classes, waiting for the permission, right? Fine. So I suggest you to do, so although I am sending the videos of 10 minutes or 20 minutes, it is equivalent to work of 1 hour and 1.5 hour. Okay, so understanding that, so you have to do some calculation work, right? So it requires time, only then you will have in a good condition. Okay, so that's the thing. So now R I have to calculate, R or Z. It is the formula 1 by y1 plus y2 plus y3. Y means admittance. So 1 by 5, 1 by 10, 1 by 20. Okay. So what is this ratio? Previously we have calculated this ratio. If you have that, that's why I tell you to write each step. Okay. So it was got 1 by 0.35. 1 by 0.35 if you make, you will get 2.85 something you will get. Okay. Approximate it to 2 or 3 decimal values. So you will get 2.86. Okay, so this is my answer. Okay, so you got now E and R values, but here only it does not stop. You need to calculate the current in circuit, right? So for that, what you have to do, you have to apply the KVL. So when you apply the KVL, what you will get? You will get this formula. Okay, from that. So this is the general formula for this circuit. Okay, so E divided by resistor value. Okay, so if I show you, so for this circuit, okay, so you have only one E and these three are in series. Okay, R plus 4 plus J3. Okay, so it does not change even if you take the KVL here in anti-clockwise manner. So you will have this minus E plus 4 plus J3I plus IR equal to 0. So then if you simplify it and write it, so you'll get E by IR, right? So R part is, so this R So what is that value we got? Okay, it is 2.86 plus 4. How much you got? 6.86. Straight away I have written here. C. Okay. So E you got 66.6 at an angle 10.78 degree. R you got 2.86 plus 4 is 6.86 in magnitude form, and J3 as it is you are writing. Now again you can use the calculator. No need to convert this into J form and doing no. So calculator will understand that. Okay. So use the bracket. So enter in complex mode. Okay. In degree, complex degree mode, 66.6 at an angle 10.78. Okay. So then divide by, so use the bracket 6.86 plus 3i. Okay. In calculator J will not write first. So you'll be writing right. Okay. So I3 if you give, wrong answers may come. Okay. So 3i you give, so you will get the answer in the J form first. Okay, not straight away you will get this answer. Okay, you don't astonish with. Okay, so that is completely different answer will come. So you write that magnitude part and then shift equal to you do. So you'll get either plus or minus J part. Okay, so plus or minus J part you will get. Note down that. Okay, I have not noted down here. Fine. So if I have to do that, so I will do it here quickly. Okay. So 66.6 at an angle 10.78. Okay. Divide by 6.86 plus 3i. Okay. So it is going to come 8.59 something. Okay. So you just verify. Okay. So 8.594488 something you are getting. And then click shift equal to, you'll get minus 1.959. Okay, you can take that only 959 or 96 you can take. Okay. 959J. So no need to write down here, only write down. Calculator you don't erase. So now just click shift plus means R at an angle theta will show answer equal to R at an angle theta. So it will give you this answer. Okay. So 8.89 or 81 something you are getting. Okay, equal to angle, next angle it will show minus 12.84. Okay, so this may be coming 8.81 something, you just verify. It depends on the how many approximation you have taken based on that. Okay, so just it will be 8.8 will come, then this term it may change. Okay, so 1 it is coming, so just you can see. Okay, 8.81 or 8.815 you can write. Okay, 8.8158149 is coming, so 815 you can write at an angle minus 12.84 degree. Okay, so this is the answer of current. Okay, so very simple, only thing is you should be perfect with calculator use. Okay, so do 2 or 3 problems, you will be familiar with this. Okay, fine, hope it is clear. Okay, if you have any doubts you can come and ask. Okay, okay, fine, we'll go for second problem now. Same way, note down. Using Millman's theorem, find the current flowing through 4 plus J3 ohm in the circuit shown in figure. Okay. So what changes I have made in this figure is, I have given here 2 sources as current source in parallel with resistor. Okay. And one, it is as it is voltage source in series with resistance. Okay. And here I am having the inductance and capacitance part in the circuit. Earlier all three were having resistor. Just to show you, begin with the AC part, I have taken resistor. At least one part I have taken easy, another part I have taken complex. Now here both part I have complex. Even the the circuit reactance part as well as the voltage part. Okay. So first what you need to do here is, so you need to keep everything in voltage source form. Okay, that is better option, right? So we have the formula. So it is very simple, right? So this is a current source in parallel with a resistor, whereas this is a single element, it does not have any source, right? This is a load, it can present anywhere, I told you. So that's what they have asked, current flowing through 4 plus J3 ohm. That is what last step we have to do. First we need to do this. So these two we have to convert into voltage source in series, and this also voltage source in series with this. Okay, so that circuit you draw first and then fill the values. How to fill the values? Again use the calculator in complex mode. So 10 at an angle 30 degrees. So what is the formula here? V I into R. So this is I and R value is here 10 plus J10. Okay, complex mode only you have to do. So use the calculator. So 10 at an angle 30. Okay, multiply with 10 plus 10i you write. Okay, so J10 means 10 plus 10i. So this is the problem you have noted down. So just we'll write the equivalent circuit. Okay, so draw the circuit one more. So here voltage source in series with this impedance, then voltage source, this is as it is, then this voltage source in series with impedance, and this load. Okay, so then fill the values. So now for this you have to convert. Okay, so what is the conversion we will get? So when you do that 10 at 10, okay, so something you had, right? So when you do that, so you'll get in first, I told you it will come in I form. Okay, so 36.6 plus 136i it is coming, so don't confuse. Okay, so 36 plus, so for this first source, first I have written all, so impedance I have shown as blocks. Okay, see here, so this is as it is. Okay, and it is upward direction, and how you give the current direction based on the voltage there. So upward was shown, right, and this downward. Okay, so this will not change, so just series you add it, 3 minus j4, and here 4 plus see here 10 plus j10. Okay, this won't change, no need to convert this, I have written here. Okay, so this is no need to do, so this is just for sake. Okay, you can convert this or is keep it as it is like that. Okay, both way you can do. So how you got this, you understood? Then you convert into angle at an theta, r at an theta. So you'll get 141.42 something, and then angle is 75. Okay, so that you have to note down. So V equal to IR formula I have used and noted down. Similarly this also. Okay, so when you do, you will get first I form, then R at an angle theta. So everything you have the calculator, so calculator, no need to note down anywhere, so straight away answers you can write down here. Okay, so one sentence you can end, performing source transformation on two current sources, so we get the circuit as shown. Okay, once you get the circuit, this can be simplified into a single voltage source in series with impedance, and then load can be shown 4 plus j3 ohm. So now to calculate this E and Z value, you'll use the formula using Millman's theorem. Okay, so hope it is clear, understanding something fine. So note down the formula, formula won't change. Okay, so now formula we need to substitute. So first source whichever you take. Okay, no need to take this only, first that, no. Okay, so here you see in the formula I have written plus only. Okay, because direction is reverse, but still I have written plus, but in the value substitution I have made minus. This is just to show you both way you can do it. Okay, otherwise I would have shown here only. So if I do every problem here only, if I show, you will feel like this is the formula. Okay, so some students will get that notion. That's why this is the formula, but value of E3 is opposite to this two directions, that's why it is taken minus here. Or else you can do this plus and these two you can minus also, you can, no such issues. Okay, so now enter this. So as I have done converted this, so you can do this or you can keep this in J form also. Anyhow, the calculator will compute it. Okay, if you keep as it is also it will work. This also okay, fine. Okay, so I have written this. So now then similarly this also. So what I suggest always here is, so I have done already angle. So always it is giving the answer in A plus BI form. So better to not to convert it into angle form in the middle, right? So otherwise double step it will come. So as it is you write whatever you have there, 10 plus 10 I, 3 minus 4j, whatever you have, the same thing you keep here also, and do the calculation here. Okay, so here steps I have shown, that's why. So first step I have to take the ratio, and these ratios I have to take first, and I have to add this. Okay, that added value in the angle form I have written 9.65 at an angle 51.02 degree. I hope you can do this. Okay, so already if you have gone regularly with the videos, and if you have done calculation along with me, definitely this is not a new things to you. Okay, definitely you will able to do this. Clear? I hope you got this answer correctly. So then in the first attempt, if the answer comes wrong, you check where I have made mistake, and again you can do. Okay, so this is correct. Then here also you take the ratio. Okay, so when you take the ratio, you'll get in A plus BI form only answer final. Okay, first you take the ratio, then add those, and final answer you convert into angle. So I will get this 0.386 at an angle 16.56 degree. Okay, so once you got this, so again use the calculator, so you'll get this answer 25 at an angle 34.45 degree volt. Everything calculator required here. Without calculator you could not do the examination at all. Okay, so that's why calculator is handy in this network theory subject. Clear? Fine. So you got the E now. Now similarly, you need to get the Y form now. Okay. So Y, what is Y or Z? It is 1 by Y1 plus Y2 Y3, right? So this is the ratio. This is the ratio whatever you have here, right? So this only you have to take 1 divided by now. Instead of E by, you should take now 1 divided by this 0.386 at an angle 16.56. If you take that ratio, you will get the Z value. Okay. Nothing much difficult. See here, this is the formula, and this already I have computed, just I have noted down here. Okay. And what I got? 2.591 at an angle minus 16.56 degree ohm. Okay. So when you have this angle, when you have the division, always angles are subtracted, and when your angles are in multiplication, they will get added up. Okay. As in logarithms, log A into B is log A plus log B, right? The same way. Okay. Log A by B means log A minus log B. Same way these angles will perform. So here it is coming numerator means minus became. Okay. And this just ratio 1 by 3.6 it will give. The same way calculator also will compute. Clear? Okay. Now finally you have to find the current I. So which is nothing but the E. E value is 25 at an angle 34.45. And then you have to add this. So this Z is as it is, you write, no issues. Okay. As it is you write. And then the load value you enter 4 plus J3. So calculator will take that in J form. Okay. So no need to do conversion. Calculator will do itself the conversion when you enter in angle and polar form, rectangular form. Okay. I have done it and I am telling you. Okay. So all I have done solved only. Okay. So do that calculation. So I hope you can do that. Okay. Not a difficult. Okay. So once you do that, so you'll get this answer. You verify. Okay. Take time. So initially it may take much time. So as you solve, so you'll be have a grip on the subject. Yeah. So you got current equal to 3.64 at an angle 15.23 degree amps. Okay. Don't forget to enter the units in the end. Okay. And answers. Okay. Ohm. In between, I am may not be writing here. Okay. So, but end answers, you need to write the units. Even in PU level also they used to tell, right? In physics, chemistry or whatever, right? The same thing you have to do. One step higher now, engineering, right? Fine. So hope you have understood these two problems. Okay. You can pause and go back. Okay. Whenever possible. Okay. So next, last problem in Millman's theorem. I'm considering the last problem. Okay. So using Millman's theorem, find the current through load resistance for the circuit shown in figure. So this sentence may almost same it will come in any concept. Superposition theorem you take. Okay. Superposition something they may change, but in Millman's theorem, this is the same statement. Okay. Either find the current through load resistance for the circuit shown in figure using Millman's theorem, or using Millman's theorem, find like that. Okay. So circuit you have to note down. So here everything is simple, right? So one is given in resistor 10 ohm into at an angle 30 degree, J10 by 10 at an angle 0 degree, and then 15 at an 40 minus J10, and the load resistance is RL now. Okay, 20 ohm. So it is a very simple circuit compared to previous one. Okay, so straight away given. So and all are in the same direction, all are plus. So simple, I think. Okay, you can do this. Okay, so just enter the formula and do the calculation. You will get the answer. Okay, so pause and note down. I will go further. Okay. Okay, so this is the question again copied down. Okay, so when you are doing solution, you have to copy down the question first in the answer booklet, right? So then this can be a single voltage source in series with Z, and then load is connected. Okay, so final circuit it is finding the current I. Now we need to find the E and Z first, and then we apply the KVL. You will get I is equal to E divided by Z plus RL. Correct? So first we'll find E formula. So this is the formula again, E1 Y1 plus E2 Y2 plus E3 Y3, Y1 plus Y2 plus Y3. So enter the values, all are in plus, no need to bother here. 2 by 2 at an angle 30 by 10, 10 at an angle 0 degree by J10 plus 10, 15 at an angle 45 degree by minus J10. So in hurry, don't do this. So this you can divide 2 by 2 times 1 to 5 times. But 10, 10, 1 you don't make because it is J term is there, careful here. Okay. So you use the calculator itself here. Okay. So use the calculator and get the answer. Okay. So 2 at an angle 30 by 10. Okay. You can use the bracket. You can do it in single step only. Okay. Plus 10 at an angle 0 degree by J10 plus 15 at an angle 45 degree minus J10. So you'll get the answer in A plus BI form. Note down that. No issues. Okay. So I have not done here. Okay, so a plus bi form answer will come. Note down. Similarly, denominator. So you have 1 by 10. Again, use the calculator. So 1 by 10 plus complex mode you use plus 1 by 10i. Okay. So J10 I have written means in calculator you have to enter 10i. 1 by 10i. Okay. Plus 1 by minus 10i. Enter this. So you'll get some answers in a plus bi form. Okay. So then take the ratio of this and this. Okay. So even if you are more familiar with calculator, you can put one more big bracket. So for this calculation, and in that only you can give the division and then this one more bracket. Okay, single step you can do. Okay. So it will give the answer straight away this minus 8.87 plus 1.6j. Even if you take this ratio, whatever answer that is, we can do it in single step in calculator. So for this brackets where you are putting everything, you should be careful. Okay, mistakes will happen. That's why I suggest you to go single step by step. Answer will not come. Okay, so always this kind of problems you have to go two-step verification. Okay, second time you need to enter. Both time if you get same answer, it is correct. So when you convert this, you will get 9 at an angle 169.73 degree volt. Okay, so this is the E value. Clear? So similarly, Z value 1 by y1 plus y2 plus y3. So 1 by 10 plus j10. So if you have that ratio already, so you can do this. Okay, so you may be getting 0.1. So that's why Z equal to 10 ohm has come. Okay, so Z value came as 10 ohm. So when you do the ratio of this, so you'll get this value. Verify this. Okay, so this is the Z value. Next, finally, you have to find the I value. E by Z plus RL. E you substitute in J form only substituted here. Anyhow you can substitute. Angle form also you can substitute. This also you can substitute. Then 10 plus 20. RL is 20 and this is 10 you got. So 10 plus 20. So you'll get this in I form. Okay. Minus 0.295 plus 0.053J. So when you convert this in angle, so you'll get 0.3 at an angle 169.73 degree amps. Okay. So this is about the problem. Okay, so very simple theorem. Even superposition you have to do, deactivation, all these things, circles are there. Okay, but Millman's theorem is the very simple theorem compared to all the 5 theorems. Okay, so that's why this is taken in the beginning itself. Okay, so statement and proof is there. Problems also you have seen in AC as well as DC. Superposition is over. Okay, fine. So in the next we will take the very important theorem called as Thevenin's theorem. Okay, so again we have the statement and proof and set of problems are there. Okay, and it is most frequently used in all the analog circuits. Okay, so if you do linear integrated circuits in next semesters, okay, so everywhere that is used. Okay, that's why this network theory is more than basic. Okay, so that's why I am taking more classes. Okay, more problems. Okay, taking as per video it should be 10, but I'm taking more videos. Okay, although it is not sufficient, you have to work along with that. Okay, fine. So whatever videos I'm sending day to day, do it on that time only. That day only you finish. But I have given the flexibility because it is there, but at the end you could not do. Already if you see, already 31 videos are over. Okay, so it is sit to one time, so it will be very huge. Okay, so that's why day to day, so I'm daily one video I'm sending, so 20 minutes or 1 hour, so just 1 hour you work on that. Okay, so there is no problem as such. Okay, fine. Okay, so day to day you do. Okay, already assignments you have, most of you have written. Okay, so test you are preparing. Okay, so do well. So that is the indication how much you have understood. Okay, so take in positive spirit and attempt it. Okay, fine. So we'll see in the next video with a new theorem in front of you. Okay, thank you.